Go on to the last lesson. Beatrice, you were such a taskmaster. My queen isn't as tough as you. But, you know, sometimes queens can be a little nice and sometimes they can be a little nasty. But our queen is nice. We call her Queen Bee. Ha ha ha. Okay, now, what we're going to do now is we're going to go back and we're going to do the final thing that you may encounter during your happy year in biology or whatever IB course you take. So basically we're looking at this table and we're going to say, okay, well, let's make this a bit bigger. I drag this over. Oh, let's center it. I can't believe I didn't center it before. This is our data, and also I think I'm just going to change this again. I'm just going to get rid of everything, start again, put a border around the outside as usual, put another border underneath. Again, different teachers have different preferences. That's just what I learned at B University. So basically what we're going to do is we're just going to do what is called looking for if there's a correlation between the relative humidity and the water content. So this is really based on a graph. So we're going to make a graph, but this time we're going to make what is called a scatter plot. Hit that. Go back to data, select data. Always the same pattern whenever you're making a graph. And what we're going to do is we're going to say, okay, let's make the y values the water content. No series name because we're only graphing one thing on there. One line. And then the y values, let's make the x values humidity, and let's make the y values water content. We have this beautiful scatter plot. Get rid of this. And then basically what I want to do is I want to put a best fit line in there. So if I go and touch my arrow to any of those points and hit the right hand mouse key, I go down and I go add a trend line, and I'm going to add a linear trend line, and I'm going to also ask for the equation of the line and the r² value. I'll explain in a second. The equation of the line is a linear line, so it's mx plus b. The slope is 0.57. But the r² value is 0.9, which is very high, which means that the data is very well correlated. It doesn't mean that there's a causation necessarily, but it definitely means that there's a correlation. So basically what it means is 1 is perfect correlation, 0 is no correlation, or you can have a -1 if it's negatively correlated. But that means at 0.94, if you get something between 0.7 and 1, that's a very good correlation. That's a high correlation. So often we use this in labs when we're looking at data, but again, we can change things. Just to review one more time, go to layout. Let's just put in the axes of the horizontal axis, title below, and we'll call this relative humidity. Do you know how humid it is in summer in a beehive? Oh my goodness, you people have air conditioning. We have to fan our wings and evaporate water in front of their hives to cool it down. That's such an interesting thing. But you guys got to spend all this money with electricity and so on to keep your house cool. What we just use our little old wings. So this is relative humidity. And let's do this right, percentage. And then we would go back to our layout. So I click on the graph, I go to layout, I go to axes, I do the vertical axes rotated, and then I just put down water content, and then I go percentage, and then it looks good. Put that in there and we have our graph made. But let's say we want to change this. Well, I think it's okay. I think it looks good. I would take this again, put it into my lab, put a figure title underneath, and I'm all set. So Beatrice, I hope this helps. Take it back to your hive, help your other little bees. I'll go back to my hive. I'm very hungry. I need some pollen and a little bit of honey to get me through the day. Take care.